and base balance, which is found in chapter 17. We're going to talk about acid and base balance in relation to regulating pH, which is in the first part of that syllabus. So acid-base balance. Basically, our body is always searching for homeostasis. When we think of homeostasis, everything has to be equal. What controls your pH in your body is your renal, your respiratory, and your chemical. They are all fighting right here to create balance. All right, that's your poorly drawn respiratory system, your renal system, and then your chemical system. Chemical system's in the middle because he acts very quickly, and he just moves in between these two things. Your renal system acts slower, but can work for longer. So your chemical system is the main thing that your body relies on to act quickly to regulate pH. The chemicals. How do we stabilize your pH in your body? Basically, when you think about it, and I know for a lot of people who haven't taken chemistry in a while, that was really hard. But when you think about it, inside of your body, you have chemicals working for you and against you. Basically, your body is trying to reduce the amount of hydrogen in your body, and we'll go into that in a minute. So it's trying to reduce the amount of hydrogen in your body. Here's the way I want you to think about pH real quick. All right, so pH. On a pH scale, it's from 0 to 14. Not that this really matters to you, but just so you know, it's pretty much like a Richter scale. It's measuring in tenfold. So this scale is actually more like a Richter scale logarithm. So if you're confused about the acid and bases, here's how you remember. And again, this isn't the best way, but if somebody, for instance, not that I condone it in any way, because drugs are horrible, but if somebody were to take acid, all right, they would be high. So let me turn this around real quick. All right, so if somebody were to take acid, they would be high. High starts with an H. All right, you might see stars, so you have H plus equals acid. All right, so H plus equals acid. When we look on the scale, you wouldn't take 14 because you'd be dead. You'd be more on the lower side of this taking acid. So again, acid, high, stars. You have an H there for high, acid for the illegal drug, and then of course you would take 1 or 2 instead of 14. So that's the way I want you to think about that. As far as your pH, just to remember that, you're at 7.35 to 7.45. Think about your age, all right? You're born, you're 0. You die, 80, 90. So mid-range of your life is 35 to 45 or middle-aged, all right? So the mid-range or normal range for your pH is 7.35, 35 years old, and 45 years old. All right, so 35 to 45, that's normal. That's middle of the range. That's where your body wants to be in equilibrium. Okay, so back to acids and bases. So the chemical, like I was saying, your chemical buffer system is trying to get rid of or create acids that are weaker. So it's going to take strong acids and it's going to turn them into weak acids, thus getting rid of some of your hydrogen, which makes it acidic. Again, H, high acidic acid. So how does it do that? Basically, I want you to think about it like a math problem. Again, if you haven't had chemistry in a while, this can be confusing. But basically, all we're doing is taking one substance plus another substance, and we're getting something new. All right, one substance, 1 plus 2 equals 3. That's what we're doing. You don't need to know any more into detail other than that, really. All of your buffer systems are going to try and create less acidic environment by getting rid of hydrogen. All right. So under your chemical buffer systems, just so you know, you have a bicarb system, a phosphate system, and a protein system. Again, same thing. They're trying to get rid of your hydrogen. When it does that, when it does this 1 plus 2, it's going to end up with products, garbage or leftovers, or but it boils down to it being pretty much water, CO2, and salt, NaCl. All right, sodium chloride, salt. So that's your products of these buffer systems. All right. The other part of this, and I'm going to continue on with that one. All right. So respiratory. Respiratory, basically your lungs again, same thing. We have to figure out how to get rid of the hydrogen. All right. How does it do this? So, your respiratory is going to get rid of CO2 and water. You breathe out CO2 and water. Your metabolism, all right, by basic function, is going to create CO2 and water, actually in heat as well, but it doesn't talk about that. So when your metabolism is going, all right, it's working, it's burning, it's doing whatever it has to do, rebuilding, restoring. All right, its products or its byproducts is CO2 and water. It's the things that the body needs to get rid of. All right, so how do we get rid of the CO2? Well, the CO2 is carried by the red blood cells. So it's carried by the red blood cells. But the red blood cells don't really like carrying CO2 like that. They want to change it to make it a little bit easier to carry. So the cell is going to take that CO2 and it's going to combine it with water, H2O. All right. So when we combine CO2 plus water, we get bicarb. All right, that's bicarb acid. Again, blood cell doesn't want to carry that much, so it's going to break that down. It's going to break it down, and it's going to give you hydrogen, all right, and then your byproduct of it, which is pretty much going to be hydrogen carbonate, I believe that's what it's called. Anyways, hydrogen carbonate. So, again, your body takes the CO2, that's a metabolic waste product, it combines it with water in the red blood cell. All right, when you combine CO2 plus water, it's able to break it up so that it's a little bit less hard to carry. All right, it's less hard to carry. I guess that's the best way of saying it. All right, so hydrogen is then carried to the lungs. Why does any of this matter? All right, well, I'll tell you why. So basically, I'm relating I drink tea, so I'm relating tea to CO2 and water, well, to water. All right, so if I have water and I have a tea bag, I have tea. But I have no tea bag and I only have water, I still have water. All right, if I have a tea bag and no water, then I have tea bag still. All right, so there's no way to end up with tea unless I have those two things. If that was confusing to you, let's look at it a different way. Basically, all right, CO2, metabolic waste product in the lungs, is taken to the lungs. So CO2, metabolic waste product, is combined with water in your cell. All right, it gives you this. Cell doesn't want to carry all this. All right, so it gets rid of this part right here. That kind of just floats off into the plasma land. This right here gets taken to your lungs. All right, let's look back. H plus, high acid. H plus makes your body acidic. All right, that's why this is important. If I don't have CO2, all right, and I only have water, I can't possibly have a product of hydrogen. So less CO2, all right, low hydrogen level. That means that if I have no CO2, then I am going to have low, I'm going to be alkaline. All right, so if I have tons of CO2, if I have a whole lot of it, then I'm going to have a whole lot of this, which makes you acidic. All right, less CO2, less hydrogen. More CO2, more hydrogen. And that's why this is important. So in your body, if it's a very acidic environment, what do you think your body's going to do? Well, it's going to increase your respiration rate to try and get rid of that hydrogen through CO2. All right, so bottom line, less CO2, less hydrogen, more CO2, more hydrogen. All right, that's why that's important. All right, so that goes over your respiratory. We still have to go over the renal system, and I'll hit on that in a little bit. All right.